Hi, everyone. My name is Cara Kuei, and I'm an engineer on the front-end team at the National Football League. I've worked at the NFL for 4 years now, actually technically like 4.5, but that's like dinosaur years. During this whole time, every time I tell someone about our team, I always get a surprise reaction. There are 3 stages of reaction. Stage 1 is, what, NFL has an engineering team? Then stage 2, well, what do you work on? Which I usually respond with, backup quarterback. Then people get really comfortable in stage 3, and they ask, can you get me free tickets? Our team manage all front-facing web products such as NFL.com, NFL Fantasy, all 32 team websites and international sites. We're also involved in the open source community and have open source projects such as React Wildcat, React Helmet, and similar projects like React Metrics, React GPT. We're a pretty busy 15-person crew. Today, I'm here to share with you our experience on working with Postmessage and React. Just want to do a quick survey. How many of you have used Postmessage? Awesome. Let's start with the basic. First of all, what exactly is Postmessage? Well, Postmessage is a browser API that enables secure communication between windows and frames. Message is a string or object that will be sent to the message receiver, and target origin is the location where the message is being sent from. And that's critical for secure communication. To listen for a message, you have to add an event listener for your component. Here's a quick example of how you would listen and receive messages. And support is pretty universal for Postmessage. It is used in every modern browser. So to give a little bit more context on Postmessage, we have this illustration here. On the left, this is a traditional relationship of a parent component and a child component that is bound by the on-click callback function. This is a closely coupled relationship. On the right, the relationship between parent-child or sender-receiver is not closely coupled. The sender is like a radio. The receiver just needs to be tuned in to the correct frequency to listen to the right station. The common term for this relationship is pub/sub. Similar to adding listeners for click, scroll, or mouse events, you also set up listeners for messages in Postmessage. The drawback to the Postmessage API is that all messages are in global scope. So it is up to you to scope the events and define the events for each message. So now, what is React? Just kidding. Y'all are here for React conference, you guys know what React is. So let's walk through some real-life examples. Postmessage has been great for us during our iterative migration and also simplified user experience for us. And before I go into the iterative migration part of it, let me give you a little more detail. About a month ago, we launched a new NFL.com. If you go to the website, you will notice that there are pages that are not built in React, and that is because we're incrementally migrating the entire insecure YUI site to a secure React site. We're constantly fielding incoming product, business, stakeholder requirements, and requests, so we're presented with a choice. Do we rebuild an entire site in the new code base or not? On one hand, we have a new code base where we got to define best practices such as using Flow, Babel, React, and so on. On the other hand, we have a legacy site that we don't have the time to redesign, reproduct, re-user experience all the pages. So the solution is that we replace critical components on legacy pages using an iframe with Postmessage. So during our iterative migration, we use Postmessage to embed our video player and to help with migration from HTTP to HTTPS. So first, Embeddable Content. This is a legacy non-React platform page embedded with a React video player. To make this happen, the easiest way was to include an embed page of our React player into an iframe on the legacy site. This way, we could keep the React code in central React code base and embed it the same way in every legacy property. We needed to use Postmessage to communicate page and video data, along with user interaction between the page and the embedded video. So let's take a look at how this is done in the background. This is a legacy page where the video will be living or be embedded onto the page. Nice graphics done by the design team at the NFL. Then we add the iframe onto the page. Then the iframe loads another route that points to the video player. Once you set up a generic set of listeners for the iframe and the parent window, and also give each iframe a unique ID to tag its message with, then you're good to go. We also set up a set of event types, some requiring data to accompany the message and others not. The user can pause the video, no problem at all from within the video, but when we need to load a video that was selected on a legacy page, we need a way to tell the player which video to load. One thing to note is definitely be mindful of unique iframe message IDs and make sure that the model can scale. So now we have more stuff we need to migrate, but our new React code base is also larger. We have utilities here that we don't have in our legacy code base. We also just received another feature request that requires HTTPS security. Let's take this page. It is our game center on the legacy platform. We still don't have time and the bandwidth to reproduct this page. We need to add a single button on this page. So we think to ourselves, how hard can it be? It's just one button. Well, that one button requires a client token, secure OAuth, secure cookie, and a user grant in order to validate that the users should even see a button. So why not iframe all the business logic from our new, secure, awesome React site? So we iframe in our functional higher-order components that determine whether the users should see a button for this game. The iframe used Postmessage to simply tell the legacy page to display a button. It's a win-win situation. We get to keep our new tools, and we also don't leak any secure data. And whoa, we just Postmessage from HTTPS to HTTP. So let me show you how Postmessage simplified our user experience for us. For our projects, we found that Postmessage provides us a way to manage relationships of components that are decoupled. While the migration is being done, we also created our own in-house content management system. And of course, it's built in React. In the CMS, we have a form that builds schemas for our content producers to use so they can create and update content. Some forms are simple, like this one, where fields are primitive types like strings and numbers, while other forms are complex, where fields are populated by data from another form. Here's an example. This is what we call a hero component. And this is what we're going to be editing in a little bit. The hero is made up of several child components. There's the title of the hero, the subtitle of the hero, there's a logo, a button or call to action, and an image. Here's a video of how the workflow would be without Postmessage. So I'm editing. I want to be able to edit the logo. So there's a button that enables the user to want to edit it. It creates a new window. I go in. I'm altering the alt tag with React Rally. I save and publish it. Now I go back to the first form, and it's not there. And I want to make sure it's there and it did save. So now I have to go and refresh the page. Then it will be there. So here's an illustration of the relationship between the two windows of the previous video. The user made a change in one window, and changes weren't reflected in the previous window, which forced the user to have to refresh. Now is a video of implementing with Postmessage. The user wants to edit the same exact logo again, edits the alt tag, saves and publishes it, and now just by simply going back to the previous window, it already populates the alt tag for it. So we wanted to make sure that we can simplify the user experience. So we use Postmessage. Once the user saves the change, it posts the changes to the other browser window. Then that field is re-rendered with the updates. And you might wonder why, well, just 2 windows. How hard is it if you just hit a refresh once? Well, this is the same form for the hero component. And in this case, let's say the user wants to create a call to action. So I create a call to action, that's 1 window. Now I also want to create a new link, that's another window. I want to create a new metric for that link, that's another window. So there's 4 windows. So if users start editing it and you have to keep going back and refreshing just to make sure that it's there, that's where it can get very repetitive. So when workflow where users have all these windows of forms open, now the user don't have to go back and hit refresh on all the other browser windows because it will just be posted to them. So now that you have a general idea of what it is, I'm going to talk about how to implement it with sending, receiving messages, and integrating with React. So when you're on a website, there could be a lot of messages being sent. Ads use post messages, video players use post messages, React DevTool use post messages. So in the browser, you can see all these messages are just popping out. And they all have different data structure. So there's Twitter for the Twitter button. And then GPT, that's for tracking, that's our own open source project. And then there's also Google Ads, which they all look different. So you have to be very, very clear and detailed with the message you're sending. You also have to know how to filter out the correct message for your component and know what to do with the message when you receive it. So let's break it down. This is how a sender would send a message. You have the message itself, and then the target origin. Technically, Postmessage supports all types of messages listed here. But you're most likely going to be using a string or an object. So then back to posting a message. You send a message that is a string or an object and pass along the origin of the message. Now to receive a message. First you set up an event listener, then you can receive the message. The message you sent earlier can be accessed in event.data. But this is not specific enough. There's no way to tell what this message means. There's no way for this component to tell what it's supposed to do with the data. Is the message meant to tell the receiver to do some computation with the data or to re-render itself? So we need to include more information in the message. Postmessage allows us to structure the message however we would like. And we decided to use JSON. It has better readability and can scale to our needs. It also maps nicely to React props. In our message, we have data and type. Data is just the data that the receiver cares about. And type is for the receiver to know what action it needs to take when the message is received. In this example, the component is sending a message that is type logging, and it is completely up to you what type of message you want to send. So now to receive the message, we grab the data from the event and parse it to a JSON. From there, we set up a switch function to handle all different types of messages. The receiver knows that the message type is type logging, so it knows how to handle the message. One thing you might notice is that we use float type. Float type provides a known structure, type checking during development. I definitely recommend it. Now you might have this question. There are so many messages coming through. Although I know it's from the same origin where I expect the message to be from, how do I know it is for my component that I'm working on right now? And you might also be wondering why I'm using a string instead of an object for the message parameter, since Postmessage does support sending an object. Remember that video I showed you earlier with a ton of messages being sent on a page? Well, We need a way to filter the message so the component can find the message it needs. So the reason we use a string instead of an object is because we also want to add a namespace to identify who the message is for when you receive it. Here. And now back to the receiver side. When the receiver gets the message, it checks that the message is not only from where you expect it to be from, it is also meant for your component with your namespace. With React's lifecycle methods, we found that a message could be lost if the receiver is not yet mounted when the senders send a message. We realized that there could be a timing issue with asynchronous messaging, so what should we do? To ensure that the message doesn't get lost in the black hole, we need to take advantage of React's lifecycle methods to ensure that the receiver is ready when a sender sends a message, regardless of the role of the component. The sender and receiver will both need to send and receive messages. And here's a visual graph of how it would work. The sender posts a message to let the receiver know that the receiver is ready. When the receiver is ready, let the sender know. When the receiver is mounted, it lets the sender know, okay, I'm ready. Now the sender knows that the receiver is ready to receive a message. The sender posts a message to the receiver. The receiver gets the message and do some computation. Once the computation is done, the message with what you need the sender to know is then posted back to the sender. The sender then will do something with the message that it just received in this case. The sender will re-render itself with the updated results. So for every component, you will need to set up listener in component did mount and make sure you tear it down in component will not mount. And the example I just gave you, in the setup page function, we'll send a message to the sender and let it know that it can now send messages to the receiver. If you remember the slide with the switch function, this is where the sender will know, okay, receiver is ready to receive a message, and the whole conversation will be handled back and forth by using the type property of the event data payload. Here are some things that I hope you were able to take with you. Postmessage is a simple and elegant API that encourages modularity. You will be more intentful by providing a known structure to the message using flow and namespace. Setting up Postmessage up correctly means you don't have to worry about race conditions when your sender and receiver are both posting and receiving readiness messages. It's easy to initialize and clean up in React. As a higher order component, Postmessage works well with React's props. And for us, Postmessage really helped to make smaller but highly effective changes to upgrade our legacy sites because there is less large-scale refactoring. It also helped us with simplifying complex, repetitive user experience. And I hope you would consider adding Postmessage to your toolkit. And I have one more thing.
This broadcast is copyrighted by NFL Productions for the private use of our audience. Any other use of this telecast or any pictures, descriptions, or accounts of the game without the consent of NFL Productions is prohibited.
Just kidding. I hope you enjoyed the talk. I would love to talk to everybody. And you can find me at Cara Kuei, or if you would like to find out what we work on, you can contact the NFL engineers. Thank you.